Hello my dear students, welcome back. So today we are going to discuss one of the important topic from your subject, that is virtual machine. Okay, I hope that you all have followed all the lectures which I have done previously. So this is the last concept from your first unit, which is also very important again. Fine. So without further ado, let's start the discussion on virtual machine. So what is virtual machine actually, why it is needed, and what the virtual machine can do, okay, how it is useful and how it is actually implemented, that we will discuss for this session. Fine. So now hope you are able to see, okay, on the screen that virtual machine, there is a definition of virtual machine. So this is a definition. A virtual machine is a software that creates a virtualized environment between the computer platform and the end user, in which the end user can operate software. Once again I repeat, a virtual machine is a software that creates a virtualized environment between the computer platform and the end user, in which the end user can operate software. Then what is the computer platform? You might have the question on your mind that, so we are calling environment, we are saying computer platform, and the end user we are saying operator software, we are saying. This is simply nothing but the name itself is telling you that it is a virtual, which means which is physically not exist, but we are saying it is a machine, it will work like it is there on your system, but okay. So here virtualized environment between means we will create one environment, there we will work into the system, that we call environment. Okay, computer platform in the sense that is operating system, whether which operating system you are trying to do. Say for example, you previously installed ms office, sorry, Microsoft Windows operating system you have installed. Within the Microsoft Windows itself, you can use many operating system like Linux, Mint, Ubuntu, Fedora, Kali OS. Many operating system are there. But previously, what you will do, you can install one operating system like Microsoft Windows. Okay, Windows. Within that Windows operating system itself, you can use other operating systems also. But how we can do that? That is done by the virtual machine. So this definition says that a virtual machine is a software that creates a virtualized environment between the computer platform, here computer platform is the different operating systems, and the end user, means we are the user, in which the end user can operate the software. Okay, so now see, a virtual machine provides an interface identical to the underlying bare hardware. What it means, virtual machine which can provide interface, okay, identical to underlying bare hardware. Bare hardware in the sense only one hardware it is there for one system, and other platforms like other operating system can use, okay, the same hardware, but it seems like every operating system is having their own different hardwares like processors, memory and all. But actually it all the other operating systems also using the same hardware. So that the first point saying, the operating system creates the illusion of a multiple processes, each executing on its own processor with its own virtual memory. It means that what the operating system will do if you are having the virtual machine. So don't get confused with the virtual machine. Here machine refers to the software. Okay, getting my point? Machine refers to the software itself, where within that software we can install other operating system and we can use it, or we can use those. But those operating system are not having any separate memory or separate CPU. Okay, but it seems like they those are also having their own processors, okay, their own memories. That memory we call it as a virtual memory, but it will create the illusion of using different processor for different systems, okay, but it is actually a same system we are using, but we are using virtual machine. Because of virtual machine we are feeling that it is having its own memory, own processor, like that. I can show you in the next class if I am able to show, but you just remember that the point is, say for example you are using Android operating system. Within the Android operating system, if you are able to use Windows, correct, using any app, you can say you can install one app. If you are using that app you enables you to, okay, access the features like a Windows, correct. The same way what we can do in our computer system is we can install one virtual machine, okay, in any of the operating systems. Say we are having the Microsoft Windows. Within the Windows we are installing virtual machine. From that virtual machine we can use other operating systems also, like Fedora, Unix, Linux. Already you are aware of it, right? VMware we are using in our computer lab, correct. The same way we are doing, that is a virtual machine. Then what is that concept of virtualization? Virtualization is an abstraction layer that decouples the physical hardware from the operating system to deliver greater IT resource utilization and flexibility. It means that abstraction layer, in the sense it is a hidden layer which is not actually there, but it feels like we are using that physical hardwares, but it is taking only one hardware from the system. That is, we call it as a virtualization. Virtualization is an abstraction layer that decouples the physical hardware from the operating system to deliver greater IT resource utilization and flexibility. We don't bother about the IT resource and utilization flexibility, okay. Okay, the second point is it allows multiple virtual machines, okay, with heterogeneous operating system to run in isolation side by side on the same physical machine. What it is saying, heterogeneous operating system, in the sense heterogeneous operating system we are saying because two different operating system can run in a single system. Getting my point? So if you are using any one operating system and you are using same supporting files for that particular operating system, we call it as a homogeneous. But heterogeneous in the sense we are having one operating system and we are using other operating system side by side by taking the help of virtual machine. That we call it as heterogeneous operating systems to run in isolation in the sense it is the same computer side by side on the same physical machine. Same physical machine refers to same CPU, okay, or your computer. Next, each virtual machine has its own set of virtual hardware, RAM, CPU, NIC. NIC means network interface card we call, upon which an operating system and applications are loaded. Here you don't get confused with the thing that each virtual machine has its own set of virtual hardware. Here we are saying that we are having set of hardware but which are virtual, okay. Say for example I have already installed Microsoft Windows. Within that I am using Linux Mint or Unix Ubuntu, correct. But Ubuntu is having its own RAM, own CPU, own NIC, but it is not actually having. It is having which is virtual. Means that software provides that it has the RAM like that, but only one RAM for one system will be there. Because of the virtual machine, it will create other RAMs, other CPU, other NIC. Okay, that is virtual RAM, virtual CPU, virtual NIC, network interface card. This is all about virtualization, okay. The operating system creates the illusion of multiple processes, each executing on its own processor with its own virtual memory. This I have already explained. Fine. Okay. if you want to see, you can see the history. Virtualization was first introduced in the 1960s to allow partitioning of large mainframe hardware. In the 1990s, researchers began to see how virtualization could solve some of the problems associated with the proliferation of less expensive hardware, including underutilization, escalating management cost, and vulnerability. This is not required for you, but if you want to, you can read that. That is a history. Okay, now you can see about VMM. VMM in the sense virtual machine monitor. The host software that provides virtualization is often referred as a VMM. Host software in the sense the first operating system which you are already having. By default operating system you can call it is a, if it is a Microsoft Windows, so that is a host. Okay, if by default it is Ubuntu, within the Ubuntu if you are using Windows, again Ubuntu is a host, correct? So that kind, the host software that provides utilization is often referred as virtual machine monitor or hypervisor, both are same. The VMM gives each virtual machine an illusion of a complete computer to itself. So it will create that illusion, it is having its own computer like that. So you can see the diagram here, it is there, virtual machine monitor. Okay, what it will do is this monitor can control VM1, VM2, VM3 up to VMN we are having. So here VM1 in the sense virtual machine 1, virtual machine 2, virtual machine 3 and go on. So this can control. Okay. Okay, one architecture I am showing you, you can see now. See here two diagrams are there, one diagram is A and diagram B. If you are seeing diagram A, their processes are there. Processes in the sense it is a program unit. Okay, program execution you can call, that we call it as a processes. So here number of processes are there, that is referred to kernel, and later third layer hardware is there. Last layer we have hardware, but here we don't have any virtual machine. One operating, say for example, for your convenience I take again Microsoft Windows is installed, it is running some programs, those programs are mentioned in the form of processes. Okay, processes, and that processes get entered into kernel. Okay, and hardware, if hardware is required it will use a hardware. So okay, this is processes are executing, it can use kernel and later hardware it can use. But if this is a system which is having any one operating system, okay, see this operating system is already there, I will install one program that or one software, that software itself if it is a virtual machine. So if you use that virtual machine, that again that also installed into this system through the interface, programming interface we call, it can create many processes. You can say processes, and each one having their own kernels, right? 1, 2, 3, like these are 3 kernels are there. VM1, VM2, VM3, virtual machine 1, virtual machine 2, virtual machine 3, correct? So I will show that how virtual machine can be used in a single system with the help of VMware. I can show in the end of this slide, I can put one screenshot, one 30-second video of that particular virtual machine. Okay, so now virtual machine implementation. So what this block does, it can create a number of virtual machines, virtual machine 1, virtual machine 2, virtual machine 3, like that, and it can use hardware. But this is the total system, correct? This is the architecture of the virtual machine. And what are the features of virtual machine? Each virtual machine has its own set of virtual hardware, RAM, CPU and IC, upon which operating system and applications are loaded. Means you can save also data that is saved into the your both virtual machine and your original system also. The operating system sees consistent normalized set of hardware regardless of the actual physical hardware. So what I am going to tell you is, if I am using my system, okay, say for example I am having a laptop. I want to use 2 or 3 operating system into my laptop. So if I am using only one laptop, that laptop can provide me that hardware, single hardware, only one keyboard. You can connect other external keyboard, that is not the part here. Hardware is refers to processor, CPU, memory. Okay, my laptop having only one processor, one memory, motherboard is only one, again system is only one. Within that system I can use a different operating system. So those operating system can be normalized set of hardware regardless of the actual physical hardware components. It means you can also use other operating system with having only one hardware part. That the point here. Benefits: partitioning in the sense multiple applications and operating system can be supported within a single physical system. This is the theme line of the virtual machine. This is the main theme of the virtual machine. Multiple applications and operating systems can be supported within a single physical system. Okay, there is no overlap amongst memory as each virtual machine has its own memory space. Obviously, if you installed any software for virtual machine like VMware, if you install within a VMware, if you have installed any operating system, those operating systems also having their own memory space. If you save any program, that will be saved into that particular disk only. Okay, isolation. Virtual machines are completely isolated from the host machine and the other virtual machines. If a virtual machine crashes, all others are unaffected. Let me say, if I am using Microsoft Windows, within that I am using Ubuntu. Okay, if I have saved any data into the Ubuntu file, but unfortunately that Ubuntu got crashed, if that got crashed, it will not affect for my basic operating system Windows. Okay, and it will not affect any files from the Windows. That is a benefit. Data does not leak across virtual machines. Obviously data will not leak. Okay, virtual machines are a number of discrete identical execution environments on a single computer, each of which runs on operating system. This can allow applications written for one OS to be executed on a machine which runs different OS, which provides a greater level of isolation between processes than is achieved when running multiple processes on the same instance. So what the summary is telling, that by using virtual machine you can run many means some operating system for a single computer, and those operating system, if you are using the data which you have saved or which you are created into those operating system, those will not leak and those will not be crashed if any one of the system got failed. So this is the whole summary of the virtual machine. So now little bit you can see how virtual machine work and how to use other operating system into single system. Whatever I am showing in the next slide means coming is about how to use virtual machine or in a single system. Okay, fine.